Hello, and welcome to Cruising Through Calculus. My name is Alex, and this part of the lecture is about factoring. You need to be really good with factoring if you're going to answer a lot of these limit problems, so I thought it would be a good idea to go over the different types of factoring you'll run into. The first factoring you'll run into, I'm calling easier factoring. I think you'll see why after we do this one. It's when you see just x squared here like this. If you see a number in front of x squared like 2 or 5, that makes it harder. This one is going to be an easier one just because of the x squared here. The method I'm going to teach you is called the x method. Some teachers have different names for it. Sometimes they call it the diamond method, and there might even be another method you learned which is very similar to what we're doing here. Nonetheless, what you do is you draw a giant x, you put a multiplication symbol up top and an addition symbol below. Here's what your goal is. You want to put the last number up top and the middle number down here. And then you want to try to find two numbers that multiply to -15 and add to 2. So for us, that would be 5 and -3. Once you've found those two numbers, you're basically done. Over here, when we go to factor it, it's going to factor into two pieces. The first piece will be x plus 5, and the second piece will be x minus 3. And we're done factoring. For this factoring problem, it is going to automatically be harder because there is an 8 here in front of the x squared. The method that we're going to be using is a bit of a mix-up. It's going to be a little bit of the x method and a little bit of something called factoring by grouping. We start off the same way as the x method, but we can't just ignore the fact that we're multiplying by 8 here. So what we do is we actually do the first number times the last number, 8 times -9. That is what goes in the top slot. The bottom slot stays the same. Now we do the same thing as last time. Can we find two numbers that multiply to -72 and add to -6? Every once in a while, you'll get a big number like this, and it's kind of hard to come up with the two numbers in your head. What you can do is write down all the numbers that multiply to 72. As you go through this list, it should pop out at you at some point. Ah, here it is, 6 and 12. So for our problem here, it's going to be, let's see here, -12 and +6. Yes, that works. All right, back to our problem here. We're not just done. We can't just do x minus 12 and x plus 6. That would not be correct. Instead, what we're going to do is actually quite a bit more clever, but also more complicated. We're going to write our first term out and our last term out. Those will stay the same. And then what we're going to do is we're going to take this middle -6x and we're going to split it up into the two numbers we found, -12x and 6x here. Then what we do is we split this in half, or group it in half. Hence the term factoring by grouping. So we've got 8x squared minus 12x over here. Here we've got 6x minus 9. Now look at the first grouping. What can you factor from here? Well, we could definitely factor a 4 and an x. So where does that leave us? 2x minus 3. We ask ourselves the same question over here. This time we can factor a 3 out. So that'll leave us with 2x minus 3. Ah, look, 2x minus 3, 2x minus 3. This is perfect. This is exactly what you want when you're using this method. Because what's going to happen now is we're going to take one of each of these 2x minus 3's and factor it out. And when we factor that out, the only thing that'll be left is the 4x and the plus 3. And now it's factored. The next kind of factoring we're going to look at is called the difference of squares. This is something that a lot of teachers have covered, and even if you haven't covered it, you can pick up on it pretty quickly. The idea is if you ever see this, a squared minus b squared, that can immediately be factored into a minus b, a plus b. Let's look at our examples here. This is such a quick one that we'll be able to go through these three pretty quickly. X squared minus 9 is going to turn into x minus 3, x plus 3, because 9 is a perfect square. X squared minus 16 is going to turn into x minus 4, x plus 4, because 16 is a perfect square. This last one over here, maybe at first it looks like a difference of squares because x is being squared, but 2 is not a perfect square and neither is 162. But if you notice that both of those are divisible by 2, you can factor the 2 out, and now it is a difference of squares. So over here, we get x minus 9, x plus 9. Don't forget that after you factor the 2 out, it does come along for the ride. The next factoring technique we're going to look at is the sum or difference of cubes. These are two different formulas, the sum formula and the difference formula. There are quite a few teachers who have not taught this, and if you did learn it, it's kind of hard to remember because it only comes up in a certain set of circumstances and, well, I mean, just look at this. This is kind of hard to remember. Let's see if we can use it in these example problems right here. X cubed minus 27 is a perfect candidate for the difference of cubes because 27 is a perfect cube. What we're going to do is follow the formula that's written over there. A is going to be x, b is going to be 3. And then minus plus plus, minus plus plus. That's really it. The only thing left to do is take that 3 squared and turn it into a 9 if you'd like. This problem down here looks like it might be a sum of cubes problem because of the x cubed, but neither 2 nor 16 are perfect cubes. So what we're going to do here is divide both of these by 2, or maybe I should say factor a 2 out. Once we factor a 2 out, we're left with x cubed plus 8. This is the perfect candidate for the sum of cubes because 8 is a perfect cube. So now, following the formula here, a will be x and b will be 2, since 2 times 2 times 2 is 8. Plus minus plus. Just like the last one, the only thing left to do is a little bit of cleanup here, where we take the 2 squared and turn it into 4. Don't forget that if you factor a number out at the beginning, that number stays along for the entire journey. There are a couple of other factoring tips I'd like to go over with you. These don't show up quite as often, but when they do, they're really good to know. Let's take a look at this first one here. We've got 3 minus x all over x minus 3. Well, rather unfortunately, we can't cancel these out because they're not the same. But luckily, we actually can as long as we're clever about it. It is actually okay to swap two pieces, like this here, as long as you do one other thing, and that is to put a minus sign in front of it. In this particular example, these will cancel out. One last tip I'd like to tell you is that the answer isn't just nothing or 0. The final answer is -1. Because the negative is still there, and if you take something divided by itself, you get 1. The next thing I'd like to take a look at is this problem here. You'll notice that it is a quadratic, and you might think, oh, I'll start by factoring, which is a really good thought. But before you do that, you may notice that there is a negative at the beginning. Anytime you see a negative at the beginning of something you're going to factor, go ahead and take that negative itself and factor it out. From here, you can proceed to factoring this. Just remember, you did take the negative out, so as you go through this, that negative will be along for the whole ride, however many steps you have. For my final tip, don't forget about the GCF, the greatest common factor. When you're looking at a problem and thinking about factoring it, take a look and see if all the terms have something in common. We used this in several different examples in the previous videos. Here, all of these are divisible by 2. So I'm going to start by factoring a 2 out from everything. You can proceed from there after you factor out, but don't forget to look for that. It actually should be one of the, if not the first thing that you look for when you're starting to factor. If you found this video helpful, you might consider checking out my website, which is linked in the description below. You'll be brought to Infinity Learning Academy, where you can find Cruising Through Calculus. At Cruising Through Calculus, we have over 100 videos and documents to help you get through your calculus class, including videos for each topic, practice problems, and full video solutions for those practice problems. I hope to see you there, and together we can cruise through calculus.